This is CERN, the European Organization for Nuclear Research in Geneva. And here, buried a few hundred feet below the ground, is the Large Hadron Collider, the world's most powerful accelerator. With a price tag of about $10 billion, it accelerates subatomic particles to more than 99.99% of the speed of light and smashes them into each other. In the showers of debris produced by these collisions, scientists at places like this have discovered a whole zoo of strange and exotic particles. And right now, they are chasing one of the most elusive. A particle thought to be essential to shaping everything from the atoms in our bodies to the most distant stars. If this particle is found, it will redefine our picture of space and fulfill a quest begun more than 40 years ago. It all started in 1964, when a young English physicist named Peter Higgs suggested something about space that was so radical it nearly ruined him.
I was told that I was talking nonsense, that I couldn't be right. So they clearly hadn't understood what I was saying.
Higgs and a few others were wrestling with a puzzle which comes down to this. The fundamental particles in the universe all contain different amounts of mass, which we usually think of as weight. Without mass, these particles would never combine to form the familiar atoms that make up all the stuff we see in the world around us. But what creates mass? And why do different particles have different masses? Try as they might, no one had been able to answer this perplexing question. Then, one weekend, after a walk outside Edinburgh, Higgs had a peculiar idea. Using mathematics, he imagined space in a new way, as something like an ocean. Particles are immersed in this ocean and gain mass as they move through it. To see how this works, think of a particle's mass like an actor's fame. And the Higgs ocean is like the paparazzi. Some particles, like unknown actors, pass through with ease. The paparazzi simply aren't interested in them. But other particles, like superstars, have to push and press. And the more those particles struggle to get through, the more they interact with the ocean and the more mass they gain. Higgs was convinced he'd made a great discovery. But when he submitted his idea to a journal at CERN, it was rejected. Undaunted, Higgs honed his theory further, until he was offered the chance to present it at Einstein's old haunt, the Institute for Advanced Study in Princeton. There, he expected his new idea would meet some of its toughest critics.
I was happily driving up the freeway, and then there was a sign to turn off for Princeton, and that really confronted me with what I was going into. I broke out in a cold sweat and started trembling, and I had to pull off the road to recover.
But Higgs persevered. It was the first in a series of talks that would convince colleagues far and wide that he was onto something profound.
Eventually, I sort of wore them down. I felt I'd sort of triumphed. So I enjoyed the parties which followed.
Today, the idea Higgs pioneered, called the Higgs field, is crucial to our understanding of space.
The Higgs field is everywhere. It's something that even in the emptiest vacuum of space has an effect. It gives you mass. So I think Higgs actually deserves credit for being one of the people that said space is stuff. It has properties in it that are intrinsic, that you can't get rid of, you can't turn them off.
The only problem? There's no physical proof that the Higgs field exists. At least not yet. But here at CERN, scientists are attempting to smash particles together with so much energy that they will knock loose a piece of the Higgs field, producing a tiny particle of its own. It's as if they're trying to chip off a piece of space.
We think that if we knock into space hard enough with particle accelerator collisions, that we can actually make a Higgs particle come out of empty space.
Our whole understanding of matter as we now have it would just fall apart if the Higgs field didn't exist.
I don't think anybody seriously doubts that we will see it. Certainly if we don't, that would be an extremely bizarre outcome.
Finding the Higgs particle would be a major milestone, establishing that the emptiest of empty space has an impact on all of matter. But it turns out that space contains an ingredient far more elusive than anything Higgs ever imagined. An ingredient that may hold the key to the greatest of all mysteries, the very fate of the cosmos.